Okay, this is section 2.2, the addition and multiplication properties of equality. Okay, so in the basic principle of this, it's hopefully relatively easy to understand that if I started off with this statement, let's say 6 equals 6, and then I decide to add something to the right-hand side of this equation. Well, now what I get is a statement that says 6 equals 8. We should all know that that's not a true statement. And the basic idea behind, and this is the same for both addition and multiplication, is that if I add something to one side of the equal sign and I don't add the same thing to the other side of the equal sign, I am now creating a statement which is not true. I am unbalancing the equation. So what I need to do is, no matter what I do to one side of the equal sign, let me erase this one. Don't need the green one there. I need to do exactly the same thing to the other side of the equal sign, so I didn't leave myself any space. So what I'm going to do is I'm going to go ahead and add 2 to the left side of the equal sign. So whatever you do to one side of the equal sign, you must do the same operation to the other side of the equal sign. These are called the addition and multiplication properties of equality, because now we get a statement that says 8 equals 8, and this is still a true statement. So if you can kind of think of it like a balance, if I have a certain number of weights, if I had 6 pounds on the left and I had 6 pounds on the right of the balance, if I start putting more weight on one side, it's definitely not going to be balanced. I would have to put the same amount of weight on the other side. Now, does it have to be exactly the same shape or the same form? No, but it's got to be the same exact amount of weight. So it's the general idea. So when it comes to solving equations, let's say we have the equation x minus 7 equals 10. And we want to solve that equation for x. In other words, we want to find the value of x that's going to make this statement true. Many of you probably intuitively could figure out, well, what do I have to start with and subtract 7 to get to 10? And that is the general idea. But what we want to start thinking about is this an algebraic way. Well, I want to solve for x, meaning I want to get x all by itself. In order to do that, what would I have to add or subtract to that x on the left-hand side there to make it all by itself? Well, if I add the additive inverse of 7, which is 7, I'm sorry, of negative 7, which is 7, I can then add this, adding straight down, I would get x. The negative 7 plus 7 is 0, so all I'm left with on the left-hand side is x. But of course, I've changed the balance of the equation by adding that 7 to the left-hand side. So what I'm going to do is I'm also going to add 7 to the right-hand side of the equation, adding straight down there. We get 17, which again, probably some of you figured out intuitively, and that's fine. It's not really meant for these types of equations. It's meant for much more complicated equations. And by the way, this is called the vertical method of adding and subtracting, where you write the number below the other number. And what you'll notice is that when I do that, one of them is on the left-hand side of the equal sign. So if you kind of make a straight line down here, that does not mean doesn't equals. I'm going to take that red line out of there. But there's a plus 7 on the left and a plus 7 on the right of the red line. And again, this is vertical because I lined the green numbers underneath of the two blue constants. What we'll do when we get to higher level algebraic stuff is we'll line up all of the variables underneath of their proper variables with all the like terms which we saw the last section. Okay, let's do a couple more examples here. All right, second example. Y plus 0.6, that's a plus, there we go, equals -1. So, in order to solve that equation for y, I would have to either add or subtract something. I need to get rid of that 0.6. Well, that 0.6 is positive. It's being added to the y. So in order to get rid of it, we're going to have to undo that operation. We're going to have to use the additive inverse, so we will subtract 0.6. But if I subtract 0.6 on the left side of the equal sign, I also subtract 0.6 on the right side of the equal sign. So the left side, y, 0.6 minus 0.6 is 0. That's gone. And now I've got -1 minus 0.6. Remember about your number line. We start with -1. If we go -0.6, it means we're going another 0.6 to the left of -1, which will put us at -1.6. So there is the y value that makes that statement true. And if you plug -1.6 back into the original equation, so if you were to take that value, plug it back into there, and then add those together, you would see that you actually get -1. So it makes the statement true. Okay. Moving on. Example number 3. We're going to solve 2x plus 3x minus 5 plus 7 equals 10x plus 3 minus 6x minus 4. So now what you should see is that I have a bunch of like terms that need to be combined first. So I'm going to go ahead and do that process first. I want to combine the like terms. I'm going to combine my x's on the left-hand side. I'm going to combine my x's on the right-hand side. And I'm going to combine all the constants as well. So the x's on the left would give me, let's see, what is it? 2x plus 3x is 5x. I'm going to go ahead and combine my constants. Now be careful. This constant right here is -5 plus 7. So remember that that is -5 plus 7. And that would be 5 to the left, go back 7 to the right, we should be at +2. On the right-hand side, again, be careful. That is a 10x minus 6x. The sign always goes to the left of the number, so that's a minus 6x. So 10x and minus 6x, 10x to the right, come back 6x to the left, we're at 4x. And then my constants on the right-hand side of the equal sign is 3 and minus 4. 3 to the right, 4 back to the left would put us at -1. So we've combined all of our like terms. Now we got to get all the x's to one side of the equal sign or the other. My preference is to take the smaller x value and subtract it from both sides, or add it to both sides depending on if it's positive or negative. In this case, the smaller one is the 4x. So I'm going to subtract 4x on both sides of my equation. Remember, we've got to keep the balance. So, and also notice I lined it up vertically underneath of the x's. I would not write the 4x or the minus 4x under the 2 or under the -1 because I'm not subtracting it from that piece. It's not like terms. So now we're going to end up with 5x minus 4x, which is 1x, or just x, bring down the plus 2 because I didn't do anything with it. On the right-hand side, now I've got 4x minus 4x, which is 0. Bring down, don't forget that's a negative 1 there. That minus goes with the 1. Now I've got all the x's on one side of the equal sign. Now I need to get rid of, just like we did in the first couple of examples, that positive 2 that's attached to the x there. So in order to get rid of plus 2, we're going to subtract 2 on both sides of the equal sign. So x plus 2 minus 2 will just be x. Negative 1 and negative 2, remember that's both negative numbers, so we're going to go more in the negative direction, would be negative 3. And if you were to plug negative 3 back into all of the x's in the original equation and simplify, you would see that the left side equals the right side when it is completely simplified. I believe if you plug them in, if you want to try it, you would get negative 13 equals negative 13. That should be a true statement. Okay, next example. We are going to solve 7 equals negative 5 times quantity 2a minus 1 minus negative 11a plus 6. All right, this time we have a bunch of parentheses there. In order to start simplifying, we need to remove the parentheses. That's part of the simplification process. So in order to do that, we'll need to use the distributive property. So the first thing I'm going to do is I'm going to distribute, remember that's a negative 5, I'm going to distribute the negative 5 to both of those. And on the second parentheses, and be careful with this one, because you do have something to distribute, you're distributing the negative with multiplication to both of these. The left-hand side of the equation just stays what it is for right now because it's nothing to do with it, it's just 7. Now when I distribute, the negative 5 times the 2a will become negative 2a because it's multiplication. Negative 5 times negative 1, negative times a negative will give me positive 5. Now moving on to the second parentheses, remember there is a negative on the outside, so when I distribute the negative, it's really like multiplying by negative 1. So it's negative 1 times negative 11a. Negative times negative is positive. 1 times 11 is 11, and then a. And then a negative 1 times the plus 6 would give us minus 6. Now we'll combine our like terms. A negative 10a and an 11a, and it looks like I've got a 5 and a negative 6. Combine those before I do any solving yet. So the left side stays 7, don't lose it. Negative 10a plus 11a, so 10a to the left, back to the right, 11a should just put it at positive 1a. Don't typically write the positive 1, just write the a. Then I've got a 5 and a negative 6, so 5 to the right, back to the left 6 would get us to negative 1. So now we're to a minus 1. Now I can solve for a by, again, balancing the equation. I need to get rid of that minus 1, so I am going to add 1 to both sides of the equation. And finally, we get 7 plus 1 on the left, which is 8. A minus 1 plus 1 is a. So we get that a equals 8. And again, if you plug the 8 back into the a's on the original equation, you should, I believe, get a true statement. Okay, that's addition. Now let's do the same idea for multiplication. When we're multiplying, again, it's the same general idea. If I were to take, let's use that idea that we started with before, 6 equals 6. Well, actually, let me leave myself a little more space there. 6 equals 6. So when I'm multiplying, if I were to multiply the right-hand side by, I don't know, we'll say 2, well, now that would be 6 equals 12. 6 equals 12 is definitely not a true statement. So what I would need to do is multiply both sides by 2, and then we would get 12 equals 12, which is true. Same exact concept. Whatever you multiply on the left, you multiply by on the right. The only thing is you can't multiply both sides by 0 because that takes away everything, because everything becomes 0. It leaves you a true statement, but it won't allow you to solve an equation. Okay, so first example. Let's say we have 5 over 2. That doesn't look very good. Times x equals 15. So what I need to do is I need to get x all by itself. In order to get x all by itself, I need the coefficient of x to be 1. Well, the only way to multiply something which is fractional by something to get 1, hopefully you guys remember, is to multiply by its multiplicative inverse, or more commonly called the reciprocal. So if I multiply the left-hand side of my equation by the reciprocal of 5/2, which is 2/5, now I'm going to end up with 1 on the left-hand side out in front of my x. But again, can't just multiply the left, have to, multiply the right. So the left-hand side should be the easiest part because you're going to get 10 over 10, which is 1, times x, so we're going to get x. Another way to think of it would be cross cancellation. 2 over 2 is 1, 5 over 5 is also 1. They cancel out. On the right-hand side, don't forget that 15 can be written as a fraction if it helps you to see that. Let me try and use a different color here. Nope, that's not working. Try this again. There we go. We'll write that as 15 over 1. A couple of different ways you could do it. Multiply straight across the top, straight across the bottom, and you would get 30 over 5, which then reduces to 6. Or you could also think of it in terms of, like I said before, I've got 15 and 5, top and bottom. 5 goes into it once. 5 goes into 15 3 times. So now if I multiply across the top and the bottom, I get 6 over 1, which is 6. Either way works. Doesn't matter in this case. The numbers don't get too big one way or the other. So x equals 6 should satisfy the original equation, which is really hard to see what that was at this point, but it was 5 over 2, x equals 15. If you plug the 6 in, multiply it out, you would get a true statement. All right, next example. If we want to solve negative 3x equals 33. So right now, negative 3 is being multiplied by the x. Well, how do you undo something that's being multiplied? In order to do that, we would have to divide. In this case, we're actually going to divide both sides by whatever's being multiplied by the x, which is the negative 3. If I divide both sides by negative 3, on the left-hand side, I get negative 3 divided by negative 3, which gives you 1, and that leaves us with an x, 1x. On the right-hand side, it's just simple division. 33 divided by negative 3, positive divided by negative is negative, and 33 divided by 3 is 11. And again, if you would plug negative 11 back into the original equation, you would get negative 3 times negative 11, which is positive 33, and that would work. So when it's a little bit more difficult to see, is something that might look like this. Y divided by 7 equals 20. Now think about the way I just said that. I said y divided by 7 equals 20. If I want to undo division, I should really multiply both sides by whatever I'm dividing by. Well, I'm dividing by 7, so if I want to undo that process, I really want to multiply both sides by 7. Now, the one on the left is a fraction, so again, you can make that 7 over 1. See that you can either cross-simplify, cross-cancel, or multiply straight across the top, straight across the bottom, get 7y over 7, which is probably the way most people are going to do it. And then on the right-hand side, we're going to get 7 times 20, which is 140. And then the 7 over 7 divides out, and we end up with y equals 140. And again, if you plug 140 back into the original equation, 140 divided by 7 does indeed give you 20, and that would be a true statement. So now what we're going to do is we're going to try and combine both of these processes. We're going to try and do some that makes you have to use some addition, subtraction, and multiplication and division properties of equality. All right, so we got some space now. So we're going to solve 12x minus 8x equals 10 plus 2x minus 13 minus 7. So we got a bunch of stuff going on here. Again, the first thing to do is to simplify both sides of the equation by combining whatever like terms you might have. On the left side, I have 12x minus 8x, which remember is the same thing as 12x plus negative 8x. So I start at 12x, which is positive. Then I'm going to come back 8x to the left, which is going to give me 4x's left over. On the right-hand side, I have only one thing that has an x in it, so I'm going to write that first. You don't have to, but I am. And then I'm going to combine all the constants. So I've got 10, a minus 13, and a minus 7. So if I start at 10, and then I go back to the left 13, that's going to put me at negative 3. And then if I go back another 7 to the left from negative 3, I'm going to be at minus 10. So now I have x's on both sides of the equation. And I need to get all of my x's to one side or the other. So the smaller amount of x's here is the 2x. I think I'm going to subtract the 2x on both sides of my equation. So 4x minus 2x will give us 2x on the left. The 2x minus 2x on the right is 0, but don't forget to bring down the 10. And remember, it's a minus 10. That minus stays with the 10. Now, to solve for x, I have one last thing to do. What I have is 2 times x. In order to undo multiplication, we divide by whatever's attached to the x. But we divide on both sides. So then the 2's on the left are going to divide out and leave us with x. And on the right-hand side, it'll be negative 10 divided by 2, which is negative 5. So x equals negative 5 is the solution to that equation. All right, hopefully you guys are with me so far. If not, you do have the ability to pause, rewind, and do all this at your own pace. All right, so we're going to go ahead and put this into some applications, more commonly known as word problems. All right, and the hardest part about the word problems, obviously, is understanding the vocabulary that goes with it and what we're looking for. So the first thing is we're going to write the sum of two numbers is 8, if one number is 3, find the other. So if you're looking at this, this is probably relatively intuitive. If I tell you to add, meaning sum, or the sum meaning add, two numbers to get 8, and I tell you one of them is 3, you can probably figure the other one out. If we write this as an actual algebraic expression, the idea is this. I know that I've got two numbers. Think of it in terms of distances. Whatever that whole thing is, that they have to add up to 8. This whole distance here has to be 8. I'm telling you that one of those is 3. So if I start on the left-hand side and I go out however much 3 spaces is, what we're really looking for is what's left over. In this case, that's kind of our unknown value. So that distance right there is x. It's the unknown value. What this is really telling me is that if I take the sum of the red and blue, it's got to add up to the whole thing, because don't the distances have to match? So if I take 3 plus x, has to equal 8. In order to solve that, I'm going to subtract 3 on both sides of the equal sign. And we'll get x on the left, 8 minus 3, is 5. Now intuitively, like I said, you probably could have figured that one out. But the concept behind this whole adding the two distances to sum up to something which is a larger whole is probably the more important piece. All right, and for our last example in this section, the vocabulary here is going to be extremely important. It says, if x is the first of 3 consecutive integers, express the sum of the 3 integers in terms of x. Okay, a lot of vocabulary. Okay, so it says if x is the first of 3 consecutive integers, here's the vocabulary right there, consecutive and integers. Integers we've talked about before. If you recall, the integers are the positive and negative whole numbers including 0. So no fractions, no decimals or anything like that. It's just the positive and negative whole numbers. It's the word consecutive. Hopefully you guys have somewhat of an understanding of, meaning in a row. So if I'm going to take 3 consecutive numbers and I'm going to add them up, it would be like saying 6 plus 7 plus 8. Those are 3 consecutive integers. You could also do it using negative numbers. We could be negative 12, negative 11, and negative 10. Those are 3 consecutive numbers, integers, that you could add up. The problem is we're given that the first number is x, so we don't know what it is. So our first integer is x. Well, if x happens to be, and this is just a guess because I don't have any idea, if x happens to be 5, the next integer, consecutive integer, would be 6. Well, how would I get from 5 to 6? Hopefully you would know that you would add 1 to 5 to get to 6. So it's the same thought process here. If I want to get to my second consecutive integer, what would I have to do to x? Well, I would have to add 1 to it. So my second integer would be x plus 1. Then if I want to get to my third integer, I would add 1 to the second integer, which is x plus 1 plus another 1, but that can be simplified to x plus 2, combining the two 1's in that one. So if I really wanted to come up with an expression that adds all three of them, and that's what I'm being asked to do here, it's going to be the first one plus the second one plus the third one. And that's an expression that adds them all. Now this can be simplified because this expression, you have like terms. I've got x, x, and x. If I add all those together, I would have 3 x's. And then I've got a 1 and a plus 2. Adding those together would give me a 3. So if I wanted to write an expression that simplifies the consecutive, the sum of the sum of 3 consecutive integers, it would be 3x plus 3. That would be your expression. All right, that is section 2.2. We'll come back with a video for 2.3, and we'll be done with the lesson for the day.